There are times when you see patterns of code repeating themselves over and over again in different methods, and you hope that there would be a better way to extract them into a class or a method. But you are hitting the limits of the C# language. My name is Gael. My team and I have developed a tool to overcome this limitation, Metalama. In this video, we will use a free edition, and I will show you how to encapsulate this repetitive logic thanks to a special kind of custom attribute called aspect. Aspects run inside the IDE or the compiler, and they can add new behaviors to your code on the fly, so your source code stays clean and concise. The objective of this video is to create a logging aspect, a logging custom attribute that you will add to some trivial methods in the beginning, and it will generate the code in green. It will add some message at the beginning, add some completion message at the end, and it will handle the return value. Let's go. If you are just getting started, I recommend you install Metalama tools for Visual Studio. It is an optional extension. Go to the marketplace, search for Metalama, download the extension, and restart Visual Studio. It is important to understand that this extension is optional. Metalama is essentially a set of NuGet packages, and it will work in any editor, even with Notepad. However, if you want more UI features like diffing generated code versus source code, syntax highlighting, you have to install Metalama tools for Visual Studio. Let's now create some code, and a very good example to get started, a very good project type is the console one. It's perfect for the logging hello world. And it's even easier if we use the old program.main, because then it is easier to add custom attributes. Okay, we have the project. The first thing to do is to add Metalama into your project. So we go to manage NuGet packages, type Metalama, and just pay attention. Do not install Metalama compiler, install Metalama framework. Once we are done installing the NuGet package, we can create a new class. And this class will be a custom attribute. So by convention, we will name it with the attribute suffix, and here it will be log attribute. We'll need one namespace, Metalama framework, and the attribute will derive from the override method aspect class. This is an attribute class, an abstract class. Let's implement it. The content of this method will override the method to which we apply this. So if we apply this logging aspect now to the main method and start the program, let's see what's happened. The first time you build a program that uses Metalama, you will notice that the build is quite slower. This is because other NuGet packages need to be downloaded at this moment. So you see now suddenly the program main method throw is not implemented. What happens? We applied the log attribute, and this method just had a not implemented exception. Another way to look at what happened is to right click here and to go to show Metalama diff, and pay attention. This option will only appear if you installed Metalama tools for Visual Studio. Then you can check that the method was replaced by the template. So that was not very useful, right? Let's now do one more tiny step and do an identity template. That means a template that will replace the method body by itself. An identity template, simply a template that calls return a meta.proceed, because meta.proceed is a special magic expression that is replaced by the original method implementation. So this template now, whose only statement is return meta.proceed, is an identity template. It replaces the original method by itself. Now, if I go back to program and I do show Metalama diff, you will see that there is no difference, just a white line. But we want to do something here. We want to do console.writeLine, and some method has been started. We run the program and we see that great. This is printed. We can even go back here, show Metalama div, and you see that indeed the template has been applied and the additional statement has been inserted in the code, which is the meaning of the template. Now let's start doing a bit smarter things, because the template is very dumb about which method has been started. So let's write instead the method name. And here I will introduce a bit of magic that is behind the meta keyword. There is a lot of magic behind the meta keyword. Meta.target gives you access to the target context. So meta.target.method will be the method to which the template has been applied. Now, if I run now, you will see the complete name and signature of the method. Great. And my next objective will be to display the return value, but because here there is no return value, let me create a different method. I will log this method too. So my objective now is to include the return value in the log. So the return value, I will store it in a local variable named result, and at the end of the template, I will return the result, but in the middle of it, I will do console writeLine, and I will say meta target method returned result. I forgot to call foo, fair enough. And we see program.foo started and program.foo returned 10. That's exactly what we wanted. Let's see at the div to see how the code was generated. And here we see, let's look closer at how the template was applied to the original method. We have the entry message, and then we define the local variable. The local variable is replaced by the original method implementation, and then we have the closing message and the return statement. What may be a bit weird here is that when we apply this template to a void method, of course, there is no return value, so Metalama just assumes that the void method returns null. But now, what if we want to improve that? What if we want to have a different template for the void and non-void method? So I would start writing an if as usually. I go to the target method, and then you see there are a lot of properties here. Okay, and here we are interested by the return type. And we say, is the return type is void, then we are going to have, we will have something, and then we will have something different. So we will call proceed, but we will not store the return value because there is none. And here we will just say that this method completed. Note that we still need to return something because we have the same template for void and non-void methods, so we need to return something, but actually this something is going to be ignored. You can see here that program main completed. The message is now correct. Let's look at the generated code. And we can see that we are no longer allocating a local variable here. However, there is still one useless statement that is just going to be discarded by the compiler. We have just finished our first aspect, logging, based on override method aspect. In the next tutorial, I will go quickly through other kind of aspects, overriding fields and properties. Our example will be a string trimming aspect. Second, introduce new members to an existing type. And the example will be automatic implementation of toString. And third, performing several transformations from a single aspect. The example will be notify property change, where we implement an interface and override property setters. See you there!